from Italy.
Okay, so good morning everybody, I'm Margherita D'Ayala and today I'm going to present my work in which I investigate the correlation of risk mapping with funds distribution, focusing on the Italian territory, and also I try to suggest a parametric function for three types of mitigation measures. Are really compared to as criteria that protect infrastructure, and in particular are not located guided me through how can actual risk reduction due to the implementation of flood protection can be computed in a standardized framework. So the aims of these works are mainly two. So firstly, to quantifying the benefit protection in terms of risk reduction, and secondly, to define a standardized cost model based just on two design parameters for three types of mitigation infrastructures. So starting with the first objective, I would like to say just a few numbers. So 91% of the Italian territory is at risk from landslide and flooding. More than 6 million people live in area at risk of flooding, and more than 1,300 people were killed by flooding in the last 70 years. About the cost, there exists, as already told, there exists a ratio of 1 to 6 in pre- and post-disaster cost. So it is really of interest to investigate and to understand the geographical correlation between implementation of defenses and funds allocations. So starting with the material, I used a RANDIS database that is a national database for soil defense project. It contains a project funded from 1999 to 2020, and this database was really useful because plenty of projects, but often records were not equally complete for many entries. So I have to integrate the database, assigning the correct class of mitigation measure, and identify the most used intervention, and I focusing on the first three. So river protection adjustment, embankment, and storage area and detention reservoir in the same class. So in blue, the project classified by RANDIS, already containing RANDIS. In orange, those classified with my integration. So in addition to the RANDIS database, I used flood risk maps produced by two basin district authorities in Italy, Autorità di Bacino dell'Appennino Settentrionale e Autorità di Bacino del Fiume Po. I used flood risk map produced from the first cycle of PGRA and second cycle of PGRA, and in these maps the territory is classified in function of the level of risk, so from R1, that is very low risk, to R4, very high risk. However, there exist some uncertainties because although the maps have a reference release date, we have not information about the time stamp period, and also there exists some differences in the way risk maps are produced, so I have to homogenize the mapping approach in order to use data in my analysis. So, the objective is to compare and to evaluate the risk reduction after the implementation of a defense. So I have to define an after and a before. So taking into account these two considerations, that there exists a time span from year of funding to the full construction, and also taking into account that there is a need of time for the collection of data and production of the map, I start from the end year of the first cycle of PGRA, and I went back for 4 years. Then I did the same for the second cycle of PGRA. So starting from the end, I went back 4 years. And then I identify the time period in which I selected, in which I can select the project. So I select project with a year of funding included in the period between 2012 and 2017. And so the flood risk mitigation respond to the criteria, and they are located in Toscana, Emilia-Romagna, Piemonte, and Lombardia. So once I define the project, I have to define the area in which I can compute the variation of risk. So considering that hydraulic defenses are not necessarily built at the location of maximum risk hazard, and also considering that mitigation infrastructure will not influence just the location in which they are built, but a wider area, I have to define a spatial dimension across which I can carry out infrastructure and 600 meters on each side of the embankment from the location of the infrastructure, and find the of influence. So, the project I can the variation of introduce is the risk score. Risk score is computed as the sum of the area at risk multiplied by a divided by the sum of the area at risk. And these risk scores are computed for the first cycle of PGRA, RS1, and for the second cycle of PGRA, RS2. It means, so RS1 for before the implementation of the RS2 means after the implementation of the defense. Of risk, and I call this index risk score, and it's the difference between the risk score after the implementation of the defense and before the implementation of defense. So since a reduction in the level of risk is expected, this value should be lower than 0. So now I'm able to answer to the question if in past years the design was based on risk assessment, and I try to demonstrate the assumption that I said at the beginning of the presentation. So whether the infrastructure are located in higher risk area and whether the economic investment led to a benefit in terms of risk level reduction. So starting with the first question, this graph shows us that just the 10% of the project were located in an area with a risk score 1, so before the implementation of the infrastructure, with a value of risk score low greater than 0.6. So just 10% have a significant risk area. And 25% of the project have a risk score 1 before the implementation lower than 0.2. So if you want to answer to the question where the infrastructure implemented, the funds invested, where the answer should be no, they weren't. So these two graphs help us to answer to the second question. So if we observe a reduction in the level of risk, so the first graph on the left side shows that just the 30% of projects have a risk or variation value lower than. So in just the 30% of the cases, we observe a reduction in the level of risk. The value are positive value, but are very low value, so they should be considered as no variation observed. The graph on the right side shows the ratio between risk score before and after the implementation of the defenses. And as you can see, more than 70% of the cases have a value close to 1, and it means that risk score values are very similar. So it means that no variation in the risk is observed. So to conclude, were the investment effective and efficient? So the term effective means an investment that had led to a reduction in the level of risk, and as already said, most of them were not effective. They are around the black line, which indicate the risk or variation value equal to 0, so no variation of risk. On the other hand, the term effective refers to investment that has a benefit-cost ratio greater than 1, and just a few projects were efficient, and are those highlighted in green. So, summarizing, it is possible to state that risk score and risk score variation could be considered innovative because no other study has been identified in literature proposing methodology for quantitative risk index and also quantitative risk variation index. However, there exists some limitation because of the lack of information in the database, but also there exists uncertainties in the date of implementation, and also differences in the production of the risk maps for different basin authority district. Could be really interesting to compare the second risk maps with those of the once they be published. Once I established that assessment is not based as a criteria for design and planning, I try to adopt a new approach phase and to suggest a cost model based on one or two independent variables for 3 types of mitigation works. And these represent a first step toward the identification of the solution that identify optimal balance between cost and benefit. I use the RANDIS database. I identify the most used intervention, and I focus again on the first 3, so river flow section adjustment, embankments, and detention reservoir. However, RANDIS, from a cost point of view, RANDIS has not a detailed breakdown of the cost associated with the project, information of the total amount of funding for the project. So it cannot be directly used to obtain parametric functions. So I have to collect extra data, and I was able to collect approximately 50 projects available on the regional authorities website. And this 50 project contains general reports, but also reports containing hydraulic and hydrological characteristics. And from the cost point of view, they contain estimated metric calculation and cost breakdown. However, not all the 50 projects contains all the information that I need for the model. And so I carried out an extra analysis of the contents and identified 3 projects for levees and embankment, 4 projects for storage works, and 3 projects for river flow section adjustment, for a total of 10 projects. So this slide shows the design variables that will be my independent variable in the project. in the model, and 2 for each type of mitigation measure. So for the detention basin, I select the storage volume and perimeter length. For the levees embankments, I select length and height of the levee. And for river flow section adjustment, I select width of the channel and length of the intervention. So now I was able to build a data sheet, a table, common to the 3 classes of work, and it represents my model. My cost model. In this model, the total cost is the sum of the construction cost and additional cost, which depends on 2 independent variables, x and y, and some parameters. Later, a regression analysis was performed in order to understand better the relationship between design variable and the predicted outcomes that are the infrastructure cost. So this slide is a zoom of the table. It is possible to identify the section of the model. So there is the independent variable section, which are the width, length, height, and storage volume, as already said, fixed parameters, and dependent variable that are a combination of fixed parameter and dependent variable. From a cost point of view, there is the construction item cost, the additional cost that are taken as a percentage of the construction cost, and then the total cost. So about the result, the cost model has a good fit with real data. On the horizontal axis, there is the actual cost, so the cost of the project. On the vertical axis, the cost obtained with the model. And in average, the model shows a little underestimation of 4% of the cost. So summarizing, we obtain a standardized cost model able to estimate cost for 3 types of infrastructure based on 2 design parameters, and regression shows a good fit with real data. However, there exists some limitation because price list varies for each region, and also there are some extra elements and some peculiarities that are not fully captured by the model. Among the future direction could be interesting to validate the model with additional projects, and also to introduce the level of protection and directly connect the level of protection with the design parameters. So to conclude, among the achievements of this work, I would like to highlight these 3. So I was able to verify that the actual risk reduction due to the implementation of the fences is not reflected in the risk maps. I was also able to confirm that infrastructure implementation and funds allocation did not target the area with the greatest need, so where the risk is higher. And also, I developed a standardized cost model using only 2 design variables. So, to conclude, the planning and decision-making for flood prevention do not sufficiently rely on risk-based criteria when there is the allocation of funds. Risk score and risk score variation can be a really useful tool for stakeholders to easily quantify and communicate the significance of risk reduction and also justify the investment that are requested. And also the cost model can provide a preliminary estimation of the investment required for each case by just modifying 2 design variables. So thank you for your attention. I also would like to say thank you to my supervisor and my research team, and also to my friends and my family for supporting me during this very long journey. Thank you.
Thank you very much, Margherita, for such a perfect timing. The duration of your presentation was perfect. So we will now move to questions from the evaluation panel. There should be a microphone, Gabriel.
Okay. Can you hear me?
Yeah.
It works?
Yeah. No, but it works.
It was working when you. Yes,
Sì, sì,
it
sì.
was. It was.
So, first of all, congratulations, Margherita, for your work. It was very interesting to read it and to see all the things you did. I know you from the master program, so it was very nice to meet you again in this today. So I have some questions, some small comments, since I was really interested by the topic of your thesis. So first of all, I will start from the second part, just for, since it's fresh. You started from a very big base, a lot of projects, but not all the information needed for all the projects. So starting from that very wide database,
Yes.
at the end, you analyzed in details only 9 or 10 projects, more or less,
Yes.
divided by LVs, retention structure, and so on.
Yes.
So the first comment is, since you refer to the Italian case study, in your opinion, can those case study be really representative of the Italian situation, or even because they are mostly located in the northern and in the central part of Italy? So in the south, for example, would you expect different results? Just a general comment.
It depends on the availability of data, because I just use open data, and the website of the Basin District Authority located in the north of Italy are really plenty of project of information. I think that this analysis should be carried out also for for project for the south of Italy, because maybe we can obtain different results, also because in the south of Italy probably less money are invested, and so it is interesting to verify if it is possible to obtain a cost-benefit ratio for the investment, a good cost-benefit ratio, yeah.
Thanks. And concerning the first part, you introduced the area of influence, the different protection measures. The definition was up to you. You decided the 2 kilometers, the 600 meters. The question is, did you use different values and then you set those values because were more representative, or you just selected those values according to the literature, for example?
Yeah, so I selected this value just making an average between which would be the area of influence for a very big river like Po, and very little river like Seine. So I make an average. Maybe the flooding area for the Po is greater than 600 meters, and for the small river is lower, so I just consider an average. And I also choose this 600 meters just because most of the projects were located with a very high for very big river. So probably if I do the same analysis for just a small river, I have to reduce the area of influence. Yes.
And, just another curiosity.
Yeah.
You have shown, you have talked about 2 different risk scores, 1 and 2. And you have shown a graph with the 2 different, that one on the right side of the slide. All those triangles refer to different measures, so both LVs. Did you try to distinguish between the 3 different protection measures that you analyzed to see if there was a particular trend, for example, in one of them, or more or less the same?
Yes, so these triangles should be also this one, in which we observe a variation of risk, correspond also a very high investment, and this these projects are very big detention basin. And so we observe that for detention basin, we can reach a reduction in the level of risk, and also which correspond to a very high investment. Yes, I can do this analysis also for the other. Yes, I just checked this one and the retention basin, these three.
Okay, thanks. So again, congratulations for your work.
Thank you.
Do the other members have any question? Okay.
Good morning. Thank you for your work, for your time. I found your topic very interesting. I think that the topic is quite actual and relevant. I have just a simple question because I was puzzled when I found your between the location of the with the actual risk level, and I just wonder, do you have some hypotheses, some ideas why there is this situation? Why this mismatch?
I point out that the maps published with the first PGRA, so was the first cycle of after the implementation of the flood directive. So it was like a new something new to do. I forgot what I was to say. Yes, so there are some maps in some projects area that were not mapped in the first cycle maps were mapped in the second cycle. So it is not possible that an area that is risk 4 in the second cycle was not a risk in the first cycle. So this is also a limitation. And for this reason, it is also interesting to compare with the third cycle of maps that will be published in the 2020, and to observe if this big discrepancy will be or not.
Okay, thank you.
Thank you.
Very well. From the panel, we still let's ask one question myself if I can. So Margherita, there was a slide in which you've shown for your cost model, the linear regression that I was just curious because most of the differences came from the third type of event, right? The yellow. Did you understand were there the other two that could justify the concentration of the deviation from the linear model just for this type of event, because the others are nearly a perfect match, right?
Yes, so probably because for river I had a project from Sardinia and one from another region, while the other one was for the other type where each of project come from a different region. So I don't know if this can influence the
Probably,
result.
maybe also related with the question by Professor Petaccio, with how things would change if you would use data from other parts of the country.
Yes, and also because there is this discrepancy between price that varies for each region, so
Okay, so thank you again, Margherita.
Thank you.
Wait. We have a surprise
Just
question.
a comment about your graph, just a comment, don't worry. And I think that your good result is the result of calibration.
Yeah.
So that if you want to propose it elsewhere, you should test your model on other independent data. Just
I have to validate the model with other projects and around Italy also.
Yes, thank you, Margherita.
Thank you.
And from flood risk, sustainability with the presentation and defense by Laura Teresa Massano. Laura, please.
Good morning, everyone. I'm here to present my thesis, In Climate Veritas. In the thesis, I will investigate using different methodologies the impact of climate variability on wine grape productivity. I will first use bioclimatic indices at the regional scale over Italy. Then I will use the same indices at local scale to move to use another methodology that use ecoclimatic indices at local scale again. In the last part, I will present to you a case study of an already implemented for the wine sector. So, climate agriculture and grape productivity can be affected by climate change. For this reason, we to better understand the climate-wine-grape relationship. This relationship using climate simulation or crop model. In general, they focus on changes in crop-specific indicators or changes in the time of occurrence of phases. Very few studies address the link between grape productivity and climate. My work will contribute to fill this gap. So, I work on Italy because viticulture is an economical asset for Italy. In fact, in the 2023, Italy was the second worldwide producer and the first exporter. These data are coming from the International Organization of Wine. Moreover, Italy is a climate change hotspot, meaning an area where the effects of climate change are expected to be more severe. My aim is to better understand how climate affects wine grape productivity using different methodologies and using observational dataset, climate simulation, working at regional and local scale. Mine can be used to build a new climatic services or and parametric insurance model. So, there are many indicators created starting from the climate variable to better describe plant-climate interaction. Here in this work, we use bioclimatic indices, those indices that are computed on fixed calendar days, meaning the season precipitation index that is defined as precipitation occurs in the last of September. These dates are, this is the growing season for the vines in the Northern Hemisphere. These dates are fixed in calendar, doesn't change the local climate. Another approach is to use ecoclimatic indices that are calculated based on the actual crop life cycle, using logical climatic indices that you can use for the time of occurrence of phenological phases that are already occurring due to the climate change. First, many factors can influence grape productivity. So, let's dive into the first part, where I use bioclimatic indices at regional scale. Usually, bioclimatic indices are used to assess the suitability of an area for harvesting grapes. Here, I present to you a new application of bioclimatic indices. I link them to grape wine productivity. I will use climatic data coming from the observational dataset EOBS, and the wine grape productivity data are coming from the Italian National Institute of Statistics, working at regional scale over Italy. Here, there is a list of the bioclimatic indices that I will use, selected after a research in literature, and some of them are also suggested by the International Organization of Wine. We have a group based on temperature and a group based on precipitation. So, the investigation is performed both with raw data and the data in order to account for long-term and interannual variability. I will apply both single and multi-regressive approach. The time series that I use in this case is 40 years long, and this is the maximum length that I was able to retrieve from the ISTAT dataset. So, here you can see the result of the single regression between each indices and the grape productivity in each region. Each maps represent the single index. The color in the map represents the correlation coefficient and when the map is labeled with the code name, it means that in that region, the correlation is statistically significant. We can see that in the majority of the region, we got the temperature-based indices positively correlated with grape productivity, while precipitation-based are negatively correlated in general. If we focus more on the total productivity variability. We also apply a multi-regressive approach in order to see if, considering a linear combination of the index, we can account for the interplay of them, and we can increase the portion of the total variability explained using the best model is chosen within using the k-fold cross-validation method. Here in the first panel, panel A, you can see the result of the correlation between the observer productivity and the productivity predicted using the multi-regressive model selected. The color represents the correlation coefficient of this correlation, and the donuts are marking the region where this is significant, and within the donut you can see which type of model in that region. We can notice that in the majority of the region, both temperature-based and precipitation-based index are selected. In the second panel, you can see the comparison between the single regression and the multi-regression. We can see that in the dark red region, the multi-regressive approach increased the portion of total variability that can be explained using the bioclimatic indices. In general, all the regions are sensitive both to the long-term and the short-term and the variability. However, we notice a slightly preference for the region to be sensitive to the long-term variability. So, to conclude, the predictive model can explain up to 52% of the historical harvest variability. On historical methodologies can be also applied with other type of climatic data. This work is now published in the Science of Total Environment with me as a first author. The next step is to use the same methodology. So it is, I use convection. That means that there are better representing the precipitation field as the indices and correlate the bioclimatic indices and correlate them to the wine grape productivity at local scale. The set of indexes mentioned before with 3 more ensemble. The productivity 2 wine consortia, one in the north of Italy, Consorzio Tutela del Franciacorta, one in central Italy, Consorzio del Vino Nobile di Montepulciano. Here, the time series that I use is 19 years long, and this is the maximum length available for the CPM data. As part of this work, I also validate the performance of CPM against jobs, sphere area analysis, and driving regional. From now on, the methodology is the same applied in section 1. And you can see the result of the single correlation between and productivity data. The full dot represents where the correlation is statistically significant. On the x-axis, you can see the single index. So we can notice that temperature-based index that are positively correlated with productivity. This is in line with what we observe at regional scale. And also, we can say that in Franciacorta, temperature seems to be the main factor affecting productivity. If we move to Montepulciano area, actually the situation is slightly different. The most important result here is that the only statistical result obtained for the precipitation-based index is obtained using CPM. So we got a positive correlation with precipitation-based index. We're actually expecting a negative one because usually precipitation can be determined by the productivity. However, many factors can influence this result, among which also the very local climate of the region. Even in this case, working on local scale, we use we apply the multi-regressive approach. Here you can see the result in using CPM, and we can notice that in Franciacorta, two temperature-based index are selected, while in Montepulciano, the multi-regressive model selects both temperature-based and precipitation-based index. Here you can see a full picture of all the regression performed in the section, the square representing the multi-regressive approach, while the triangle represents the single regression approach. You can see that in general, the multi-regressive approach is able to explain a higher portion of the total variability of the productivity in compared to the single regression. Working at a local scale, we improve the result obtained at a regional scale. And also we observe again that the multi-regression improved the portion of productivity variability explained by the bioclimatic indices. This work is now under review and is available as a preprint in the EU sphere. A work like mine can serve as a foundation in using CPM in future impact studies, especially when convection is a dominant factor or high resolution is needed. Now let's go to part 2, where I use ecoclimatic indices at the local scale. So again, the I mentioned before. So crop life cycle is changing due to climate change. And I show you an approach that uses ecoclimatic indices able to compute, that are computed on the actual crop life cycle during relevant phenological phase that to compute these phases, we use and these indices, we use a phenological development model. The model, the phenological development model, is based on the grape variety, the geometry of the canopy, meaning how the vineyard is built, and the geographical coordinate, so where is the vineyard. There are also settings based on some agronomical values, for example, the sugar level at maturity. The model input climate data that in this case are coming from EOPS, and it output the time of occurrence of the phenological phases, and on that period will compute the ecoclimatic indices. To better understand how the model works, here's a picture. So notice that he takes in account also the year before harvest, because the cycle is approximately 2 years. So it's important also to account for the year before. In the top part of the picture, you can see the key phenological phases that the model is able to compute when specific period will occur based on the setting that we impose, so the variety, the geometry of the canopy. On that period, we will compute the ecoclimatic indices, for example, the frost stress index. To stress that these are not in the calendar as for the bioclimatic indices. So, analysis is performed in Franciacorta and Montepulciano at local we set the model for the area of Franciacorta, we impose the variety Chardonnay, he computes the ecoclimatic indices, and then these ecoclimatic indices are correlated with the data for the Terre di Franciacorta white. When we have more than one variety allowed for that type of wine, we run the model multiple times. And here you can see the result of the single regression between ecoclimatic indices and the productivity data. This is the appellation Terre di Franciacorta red. In this case, we have 2 varieties allowed, Cabernet Sauvignon and Merlot, and we have again the full dot representing the statistical significant result. In this case, we got a positive correlation with the Eco 5 in the year of the harvest. This is a frost stress. This result is somehow unexpected because the frost stress during the year can damage the production. However, frost stress is very localized, so very local condition can influence this result as in the setting of the model, or the fact that we actually don't know the exact percentage of Cabernet Sauvignon grapes that goes in that appellation, so that can add in any case, further investigation are needed to better understand this part. However, if we move to focusing on another appellation, Terre di Franciacorta white, we got exactly what we were expecting. meaning, in this case, meaning a positive correlation between this index in the year before harvest and productivity. In this case, the only variety allowed was the Chardonnay, and that means that there weren't any water stress in the year before harvest that is good for the harvest of the next year. Even in this case, we apply a multi-regressive approach, but using the leave one out cross-validation method, imposing that the model will have a maximum of 3 predictors. Here the result for the Montepulciano area using Merlot variety, that we have a model, multi-regressive model with good predictive skill, as shown the adjusted square. And the index, eco-index selected by the model, the one listed here, some based on solar radiation, other again on water stress. Even in this case, we compared the performance of the single regression approach and the multi-regressive approach, and we got that the multi-regressive approach is able to explain a higher portion of the total variability of the productivity. However, in this case, the added value of the multi-regression is not that straightforward as in the first and second section. So to sum up, using ecoclimatic indices, we were able to work on specific key phenological phases that are important for the stress, for the plant stress. We work again at local level, made in a tailor-made analysis. Modeling grapevine productivity is challenging. However, we were able to obtain a model able to explain up to the 50% of the total variability of the productivity. Again, this methodology can be also applied using convection permitted model or other climatic data. Now let's move to part 3. Let's change setting and let's change country, because now we move in Portugal. So in Europe, we leave Italy for Portugal, and in this part, I will show you a case study of already implemented climate service for the wine sector. Here, the aim was to propose a user of this that is based on the accuracy of the product. The climate service is offered by MedGold project, that is an European project dealing with the impact of climate change on olive oil, grapes, and the durum wheat. Here I evaluated the performance of the seasonal forecast in the MedGold dashboard that are coming from the CS5 project, and I compared them to the ERA5 reanalysis. We focus on a specific case, so the prevention of fungal disease and sunburn. This means that among the many products available in the dashboard, we focus mainly on these three bioclimatic indices, among which the spring rain, that it was also mentioned in section 1 and 2. So the performance of the seasonal forecast are evaluated to propose a fair fee to the user in the Douro region. We evaluated the performance metric for each of these bioclimatic indices, among the hit rate and the accuracy, and then we ask ourselves how the user can react to the forecast, to the product that we are providing them. So we imagine to have 3 types of user. One is the reactive farmer that actually doesn't care much about the forecast, and they act based on the present condition. The prepared farmer that is somehow the middle way, because it consult the forecast, but it also act on their own experience, and the proactive farmer that actually assume that the seasonal forecasts are always correct. Based on these 3 types of character, these 3 players, we made a cost analysis evaluating the cost of inaction against fungal disease and sunburn. Any type of action, any train of action will result in different costs. We compute the different cases, and we evaluate that the cost of inaction range between 600 and 900 euros per hectare. So that means that for 100% forecast accuracy, for a hotter than normal and wetter than normal year, a farmer can save more than the 15% of the annual income. Hotter than normal and wetter than normal year are years where the fungal disease are more like to occur. That's why we focus on that years. So since that in the Douro region the forecast accuracy is close to 50%, we propose a climate service fee of 20 euros per year. The fee proposed is high enough to cover the maintenance cost of the dashboard, but also improve the product available there. But it's also fair for the user because they can afford it, and also it's a good thing for them because they can prevent losses due to the fungal disease. Also, this work is published in the Climate Service Special Issues with me as a second author. We here evaluated the fungal disease and sunburn, but the same methodology can be applied on different products, meaning also different bioclimatic indices available in this case in the medical dashboard. We suggest as a best practice for the users, for the provider, to also show the performance metric of the products in order to build trust in the user. So, to sum up my In Climate Veritas journal, I first show you a new application of the bioclimatic indices at the regional scale over Italy. Then apply the same methodology at the local scale, but using a convection parametric model. In the third section, I will show you the approach that use ecoclimatic indices. And then in the last part, I show a case study of a climate service for the wine sector. So, in general, grape productivity is influenced by many factors, and the wine business is heterogeneous. Any kind of study, in this sense, must account for this heterogeneity and this complexity. I work at different time and spatial scale. Both bioclimatic indices and ecoclimatic indices are a good tool to predict grape productivity. However, in the face of climate change, the ecoclimatic index can be a better fit because they can account for the shifting of the phenological phases. I work on historical data, but the same methodology can be applied on seasonal forecasts or can be used in conjunction with future climate projection. So, thank you all for listening.
Thank you, Laura, for another presentation, very much on time. Now from the evaluation committee.
Hi, Laura. Thank you. Congratulations for your works. I really appreciate your topic. I have some considerations and some simple questions. The first consideration is that you more or less the same results at different spatial scale. So the question is, what do you think? What do you learn about your experience? And why it seems that the maximum explained variable that you can reach is the same, despite you use a very specific case study and also a very large spatial scale. Well, what is your idea about?
In my opinion, is the fact that, that I mentioned in the introduction, meaning that there are many factors besides climate that influence productivity. And there are, for example, the policy related to how to produce that type of wine. This could be one of the reasons why. So both bioclimatic indices and ecoclimatic indices can do so much in order to explain this variability. What I learned is that the quality of data and quality of metadata available both for the climatic part and for the productivity part are very relevant. In fact, as I showed to you, working at local scale, we improve the result obtained at regional scale because we got a higher resolution, of course, but also because we were able to interact with the wine grower, the consortia, and they were able to give us a lot of information, a lot of metadata about what was happening in specific year that we are focusing on. So that was I
Probably I was expecting a more big difference between the results
scales
at different scales, yes. But
yeah.
I really appreciate also your attempt to use the ecoclimatic indices, because I think that it's really the best that we can do.
Yeah.
But I was a question about the model you used. do you wonder about the model uncertainties? Because yes, it's nice to use a phenological model to define a better period for the calculation of the indices, but you also should trust the model. So do you explore the uncertainties about the interannual range that the model gives you?
Yeah, we ran the model. We had, I wasn't enough time to speak about it, but we made some a sort of sensitivity analysis of the model. So we were able to run the model with different settings and compare the result between one run and each other. So working like that, we can have some kind of an ensemble of runs that give us an impression, a sort of a measure of the uncertainty related to the computation of ecoclimatic indices. Then there are, of course, we must consider the uncertainty from the source data that are the climatic data that we put in input. The definition and the computation of the ecoclimatic index is also something that is a work in progress. Every day. So we run the model. We work extensively. After an extensive work on the model, we were able to say, okay, now we have to stop here, run the model with this. I think that is the best that we can have right now. But of course, it's a never-ending work to improve the model to account for uncertainty and.
Another consideration about part 3 of your work.
Yeah.
Very nice, congratulations. I don't know if other people here know, but the major costs that farmers have to address in agriculture are due to pest and disease. But we often work about and study the abiotic stress, about temperature, precipitation, and so on, because they are simply they are easy to study. So I really appreciate your work, and I found it quite interesting, and also the fee that you computed, it's incredibly low.
Yeah, it must to be are very localized, and the numbers that you saw are based on the extensive interview with the user. We have, as part of the project, a business partner that is Sogrape Vineyard, Sogrape company, and they provide us their prices. So in this case, it's 20 euros per year, but it's based on the market value of that wine in that region. So it can vary a lot from an area to another. And also, we focus on fungal disease because they ask that. So the user asks us, our main problem is this. What you can do, what the community, the scientific community can do to improve, to protect our income from that. And always thanks to the user, we select the bioclimatic index that I mentioned, because they were saying, okay, according to our experience and also according to the agronomy that they have in the company, the rain near the spring is a problem. Then there are the heat stress and so on. So we were able to point out, to really pinpoint the problem.
Fine. Thank you.
Thank you too.
More question?
Hi.
Thank you for your nice presentation, well addressed. I'd like to ask you if your methodologies can be used also for other crops.
Yeah, of course. The methodologies, so the use of bioclimatic and ecoclimatic indices can be applied with on other crops. In this sense, I would say crop that are perennial, because the life cycle of a vine is 2 years, but a vineyard will last 20, 30 years. It will be productive for 20 years. So I will use these for, let's say, perennial crop. But there are many, for each crop, there are specific indicators built for that crop. So the methodology is the same, we just change the set of bioclimatic indices that we will use.
Have you some personal experience in this way?
Using the bioclimatic on other crops, I study something related to the to food crops, so cereal or soy, but just as part of from my education program in the doctorate.
Thank you.
Thank you.
Any other question from the... Okay, so thank you again. Laura. And the third and last defense of the morning, the last presentation, is about chemical safety and sustainable depollution. Antonios Stratidakis from Greece, please.
Can I start? So hello to everyone. Thank you very much for the opportunity to stand before you and also for the opportunity to be able to present the thesis conducted during the last 4 years under the supervision of Professor Denis Arizanis. The title of my PhD thesis is A Holistic Approach Toward Chemical Safety Assessment and Sustainable Depollution Innovation. So, as we know, humans are exposed to chemicals, including metals and atmospheric pollutants, from conception until the last days of life. These substances are considered to be hazardous to human health, and exposure to these substances is an issue of paramount importance for the European Commission and also for many health and environmental organizations. Additional exposure to these substances may lead to numerous adverse outcomes on human health, including carcinogenic, neurotoxic, immunogenic, and thyroid effects. Exposome is a new term that was firstly introduced by Wild and his team in 2005 and aimed to address the totality of environmental exposures across the complete lifespan. And it's divided, as you can see here, in external exposome and internal exposome. There are 3 main exposure classes to which we focus in our study: the occupational exposure, the environmental exposure, and the consumer exposure. Additionally, there are 3 main routes of exposure which we take into consideration: the oral exposure, the exposure, and the inhalation exposure. The current PhD thesis navigates through different stages of risk assessment by making use of state-of-the-art methodologies in order to strengthen the current research and act as a springboard for the establishment of new policy initiatives by the European and international health organizations. As you can see here in the figure, we particularly focus in 3 main components of risk assessment, including the hazard identification, the exposure assessment, and also the risk characterization. So this is, in this slide, I present you the total exposome workflow, which implements different methodologies towards the conduction of exposure assessment, risk characterization, and hazard identification. In total, I will be presenting you 6 studies. The first 2 are case studies, which assess the exposure of different population groups to metal emissions. The first case exposure, and the second case study focuses on the exposure of the entire population of a small city in Russia, which is based near a cement production plant. With the third study aims to estimate the exposure to arsenic and the risk characterization of different population groups across Europe with the use of modern state-of-the-art in silico toxicology tools. The fourth study aims to implement the exposome paradigm through an integrated approach to investigate the impact of early life exposure to metals on child neurodevelopment. The fifth study makes use of a very modern term, a concept in the field of toxicology, the adverse outcome pathway, the AOPs, and tries to navigate among the current state of the art in order to set priorities for further research. And the sixth study step forward, and instead of only assessing the exposure and the hazard of originating from the exposure to pollutants, it proposes the development of new green technologies in order to degrade atmospheric pollutants and thus to provide a safer environment for the citizens. So, as I said, the first 2 case studies. As we know, the particles in welding fumes, which are generated throughout welding procedures, pose serious concerns to the welder's health. since they are particles mainly in the PM10 fraction, which means that makes it harmful for human health because they can surpass the respiratory tract. And also, additionally, the production of cement is associated with the emissions of dust and particulate matter, and also atmospheric pollutants, which can generate also many harmful effects. In both studies, we focused on the spatial distribution of the PM10 particles, their morphology, and their elemental composition. And this is very important because, as we know, the hazard of the particles, either they are welding fumes or they come from industrial emissions, depend on their composition. So here I present you the methodology followed for the collection of samples for the 2 case studies. On the upper side, you can see the workplace and the filters registered in order to collect the samples. There is a zone 1, which is here in the center, and it represents the welder's immediate breathing zone, which is far away from the welder, although we tried to estimate the partial distribution of the PM10 particles. We used in total 4 very well-known industrial electrodes, rutile basic, acidic, and rutile cellulose, and also we applied 2 constant currents of 100 and 150 amperes. In the second case study, you can see here, this is the map of a small town in Russia, Primorsky Krai, which is it's situated near the cement plant. You can see here the 10 sampling points. Point 3 is the center of the plant, point 1 is the entrance, point 6 is the center of the town, and point 9 is the local forest. And in order to collect the samples, we collected conifer needles from the trees, and we washed out with a specific methodology, and we analyzed these samples. So here I present you the particle size distribution analysis for the 2 case studies. In the upper side, it's in zone 1 and zone 2 of the welding workplace. You can see in, I don't know if it's very legible, because yes, we used all 4 types of electrodes, and we applied the 2 constant currents, 100 amperes and 150. And in gray, the 150 amperes. You can see that the particles generated when we applied 100 amperes where the particle size distributions range within 10 and 30 micrometers in diameter, while when we increased the current, the particles formed were even smaller into the PM10 range, and also partially into the PM1 range. On all sampling points from 1 to 10, and you can see in the town, the Russian town, and you can see that mostly the most abundant percentage of fraction was identified for the PM10 fraction. Here I have some SPM images, scanning probe microscopy. You can see in the upper side of the slide the images taken for the particles generated through the use of all types of electrodes. You can see that in some cases we can have some aggregates, but more or less all the images correlate with the results of the particle size distribution. And also on the bottom side of the slide, you can see the conifer needles before and after the treatment. So here you can see the microparticles, and here they are washed out in order to get analyzed. Here you will see the results of the elemental composition. On the bottom, you can see the elemental composition of the particles collected from the arc welding operations, and you can see that in all cases manganese and iron report a great percentage in the total percentage of the elements. And this is very hazardous, we have to say, because this combination is known very well to the Welders Health and Organization, because they are known to generate specific lung disease, which is called pneumoconiosis. Also, on the upper side, you can see the elemental composition of all the particles collected from 3 different points of the town, and you can see the abundance of elements of potassium, titanium, manganese, and copper. So, to conclude, demonstrate human health and stress the real need for their control and mitigation. In the third study, we aim to conduct a comprehensive risk characterization of arsenic for countries across Europe, supported by an integrated exposure modeling framework. Human biomonitoring data of various population groups and toxicological reference are being used in combination with the latest state-of-the-art modeling and reverse dosimetry tools. Exposure reconstruction relied on these human biomonitoring data from blood samples. Additionally, data were ranked by educational level, medium, high, and low, and biological sex for participants from different countries across Europe. And focus was given, we have to say, to several population groups, including infants, teenagers, adults, and pregnant women. Towards our aim, we used the integrative computational software that encompasses the calculation route from an environmental release to internal dose in a time-dependent process, incorporating Markov chain Monte Carlo probabilistic analysis framework. It's worth noting that this software was developed by Professor Sarydzanis, and here you can the estimates of the external exposure based on these blood HBM data. In the upper left figure, you can see the results of the exposure reconstruction of arsenic based on blood for participants from Belgium, and more specifically for male adolescents and also from female newborns. As you can see, the highest arsenic intake was reported for male adolescents here. Additionally, on the right side, you can see the arsenic intake estimated for adults in Norway of different educational levels, high educational level, medium, and low. And you can see that the highest intake was reported for the highest educational level. On the same direction, you can see the data, the arsenic reported graded arsenic intake of up to 0.236 microgram per kilo body weight per day. And, at last you can see the results obtained for many population groups in Europe. You can see that pregnant women in Norway reported the greatest arsenic intake comparing to pregnant women in Belgium. Here we will estimate the arsenic internal concentration for the same population groups. Once again, pregnant women from Norway reported greater arsenic intake comparing to pregnant women from Belgium. I think it's interesting to say that a population group to which we focused was teenagers from a hotspot in Belgium and teenagers from a non-hotspot area. And as you can see, once again, the results of arsenic internal concentration were reported to be higher for the teenagers in the hotspot against the teenagers in non-hotspot areas. In this slide, I present you the results from the risk characterization, which was based again on the same HBM data. We used this equation in order to estimate the margin of exposure, and we obtained the toxicological reference value from EFSA with a benchmark dose limit of 0.1, which means that within the range of 0.3 micrograms kilo body weight per day and 8 micrograms per kilo body weight per day, there is an increased risk of 1% for the generation of skin cancer, lung cancer, and bladder cancer. You can see that the high risk was reported for adults in Norway from 20 to 59 years old, and also when taking also the upper limit, also we had the same results. I will proceed to the next study. I'll try to be as comprehensive as possible. So the fourth study aimed to draw an association between the exposure to metals in early life in children of 3 to 8 years old with neurodevelopmental disorders. For this reason, we conducted the Heracles Greek cohort, which focused on the impacts of early life exposure to heavy metals, originating from a waste disposal site on child neurodevelopment in Athens, in Greece. In total, 300 children from 3 to 8 years old were enrolled, who lived in the proximity of the landfill and in maximum distance of up to 12 kilometers. You can see here the map of Athens. This is the landfill to which we focused to. The exposure to heavy metals was assessed to understand the association between neurodevelopmental factors. Biosamples, concentration of different metals were analyzed in biological samples collected from the children, and also the same analysis was conducted for soil. This is the methodology. We initiated with the Heracles cohort. We distributed the questionnaires to the children and to the parents of the children with regard to socio-demographic data, child physiology factors, and also some dietary parameters. And we then collected biosamples from the children, hair, urine, and blood, and we collected also soil samples from the living address of the child and also from the landfill. We then conducted a metabolomic analysis with the use of ultra-pressure chromatography, and also with the use of ICP-MS, we we measured the exact concentration of metals in both the soil and the human sampling. We then conducted a pathway analysis, and we concluded an exposition-wide association study. It's worth noting also that the questionnaires included also the Wechsler Intelligence Scale for Children, which was used to provide information on the intelligence quotient, on the IQ, or the mental development of the children. Here you can see the concentration in in biological matrices in the upper side of the slide. You can see that the most abundant metal in hair was mercury, and in blood it was arsenic. Also, the concentration in soil, in this figure, you can see that in soil the most abundant metal in the landfill was lead, and in the living address of the children was manganese. Here there is an exposure parameters Hitman which correlate the factors. You can see here, I have put some arrows in order to be more clear. The distance of the living address was found to be highly negative, associated with the concentration of mercury in soil, and in addition, white fish consumption is highly correlated with the concentration of mercury in hair. The significance of these results is associated with the impact of exposure to mercury and manganese on children's neurodevelopment. At last, you can see a volcano diagram, let's say, which depicts the association of IQ with the environmental, dietary, and exposure factors. Below the dotted line, which is the significant threshold, you can see all the factors that were not significant. On the right side, you can see the factors that have a positive correlation with the IQ of the children, and on the left side you can see the negative correlation, the factors who had the negative correlation with regard to the IQ of the children. Now, For our fifth case study, we used a very modern toxicological term, which is called the AOP, the Adverse Outcome Pathway, and which is a conceptual construct that portrays existing knowledge concerning the linkage between a direct molecular initiating events, as you can see here, at a biological level, relevant to risk assessment. This concept, the AOP concept, facilitates the rapid hazard assessment for human health risks, and since it's a modern concept, AOPs are constantly evolving and their number is growing, and they are referenced in the AOP wiki database, which is an online repository. We conducted two sub-case studies in order to identify the AOPs that are linked with developmental neurotoxicity and also the AOPs which are linked with adult neurotoxicity, the neurodegenerative ones. In total, for the DNT, the developmental one, we conducted a research in this repository, the AOP wiki, and we identified in total 12 AOPs that are linked with developmental neurotoxicity, and we identified, we built here, you can see AOP network, and which conclude for adverse outcome, including neurocognitive disorders, neurodegeneration, disease of inner ear, and structural developmental anomalies of the nervous system. We did the same for the adult neurotoxicity in order to navigate through the current state of the art and what is already available in terms of knowledge. We identified 16 ANT AOPs in total that led to 7 adverse outcomes, including Parkinsonism, neurodegeneration, oxidative damage, disturbances of smell and taste, and epilepsy or seizures. Based on all these findings and the search that we conducted, we developed 3 priorities for the next years. Priority 1 and 2 are linked associated with the development of AOPs that are linked with developmental neurotoxicity, and they aim to develop an AOP that will provide evidence for the dysregulation of the glycolysis and also here on the second priority of the TCA cycle after early developmental stages exposure to endocrine disrupting chemicals. And the third priority was associated with adult neurotoxicity and aimed to support the AOP's network for under the Alzheimer's disease. So now we took a step forward, and we didn't stay only in the field of assessing the exposure to pollutants or the hazard identification. Based on all the lowlands that we obtained from the aforementioned studies, and under the new concept of SSBDs, safety and sustainable by design, we developed new technologies based on nanotechnology that are able to degrade organic pollutants, atmospheric pollutants, and also have a very high efficiency of photoreflectance. These new technologies represent a new bioclimatic project in the form of a green roof tile. And the reason that we proceeded with this study is that we aim to address the issue of environmental pollution and the European and global energy crisis. Again, we have set a number of criteria, such as the low cost and sustainable production, the research data that occurred from the previously conducted studies, and also the current literature. We aimed to achieve a great photocatalytic activity and great photoreflective efficiency of the final product, and also we took into consideration the demand of the European Union to make Europe climate neutral by 2050 under the European Green Deal. This is a milestone for our development, for the development of our product, because in 2021, European Chemicals Agency classified titanium oxide, which is widely used in everyday products such as toothpaste or in paints classified it as a potential carcinogenic substance when inhaled, and thus we took this into consideration and we proceeded with the development. We used two polymers of titanium dioxide, the anatase and the rutile, and also two types of polymeric materials, the polyethylene glycol and the pluronic F127, which is a copolymer of polyethylene glycol. This is the methodology that we followed in order to develop the new nano... Yes, this is the methodology that we followed in order to develop the new nanomaterials. We conducted a number of characterization techniques in order to characterize them and to be able to know with which nanoformulations for the implementation in the final product. The most important probably is the Brunauer-Emmet-Teller method that you can see here, which estimates the specific surface area. The greatest the specific surface area, potentially the greatest the photocatalytic efficiency of the final nanoparticles. And also you can see here scanning electron microscopy images, the nanoparticles that are placed onto the surface of roof tiles. Thus, what we did is that we took roof tiles and we coated their first surface with the new nanoparticles, and also, given the fact that the new classification of the titanium dioxide that is potentially a carcinogenic substance, we embodied with a new methodology. We incorporated the nanoparticles into the body of the tiles. You can see here the pictures. We measured the reflectance in the simple natural red clay, in the roof tile that had only the nanoparticles coated, and also the new embodied nanoparticles into the roof tiles. And we found out that the best efficiency was reported for, indeed, for these roof tiles in two different ratios of raw material and nanoparticles. We measured the photocatalytic efficiency, and for the final proposed product, we found out that the nitrogen monoxide degradation could be, the nitrogen monoxide could be degraded by 15%, and the nitrogen oxides, you can see here also in the figure, by 11%. This is as conclusions. It is considered that this study will have a high impact on future studies in the field and on the depollution of the urban environments, and will hopefully initiate a strong dialogue with municipal authorities for their extended application. At the moment, we are trying to establish a patent with Professor Sardanis for this as a product. General conclusions. The results reported in the first two case studies on the exposure assessment of the two different population groups. The results demonstrated the high risks originating from industrial processes such as cement production and arc welding operations. In the third study, which focused on the exposure of different population groups in different countries across Europe, it was demonstrated the great importance of considering both geographical and demographic factors in assessing the exposure of arsenic and its potential health implications. And in the fourth study, the results demonstrated that beyond diet, there are several other factors that have proven to be influential for child neurodevelopment. As future perspective, due to the vast increase of exposure to chemicals and environmental pollutants affecting adversely the human health, and the UN upcoming data regarding their hazardous effect, a need for the development of new methodologies has emerged in order to assess efficiently their hazard. Chemical assessment to date has made mostly use of in vivo methodologies which require animal testing, a procedure that has proved to be very time-consuming and particularly expensive, while it also raises ethical issues. The integration, what we propose is in the future as methodologies is the integration of different omics technologies under a multi-omics analysis, including metabolomics, genomics, proteomics, and transcriptomics, which can lead to a better interpretation of the molecular mechanisms in disease processes. The AOP concept to which I referred earlier can be an appropriate tool for the systematic classification of knowledge, offering immense potential within the regulation. Last, increased efficiency in chemical hazard and risk characterization can be provided by integrated approaches to testing and assessment, IATAs, which are able to combine multiple methods, such as in silico toxicology and in vitro and regulatory toxicology techniques. In total, with regard to the dissemination of our results, we have already produced 8 articles based on the research conducted under the PhD thesis. We have also published 2 chapters in the most prestigious, let's say, toxicological encyclopedia. And at the moment, I currently lead the activities in the biggest, let's say, project in the world, worth of 1 million, for the development of new AMPs that are linked to developmental neurotoxicity, and also the same for the effect markers group. So that's all for me. I would like to say that this thesis was conducted within a Marie Curie, Sklodowska-Curie action in the project Neurosome. I would like to thank my professor, my supervisor, Professor Dennis Saridjanis, whom I will meet in 2 days in Lisbon to present in Park in a meeting these part of these results. I would like also to thank my colleagues, Amir, Mujahid, who are here, Alberto Gotti, and Venetia Kokaraki, who could not be here because she is in labor. And also, I would like to thank the administration of use, Valentina, thank you for everything. And I devote all my efforts to my family and my grandparents who are not here, but I devote them all my efforts. Thank you very much.
Thank you, Antonius. So, questions now from the evaluation committee.
Congratulations for your presentation. It is not simple to summarize 6 different studies with high-level methodologies. At this regard, I would like to ask you, you talked about the safe, sustainable by design in the 5th studies, but in the exposome perspectives, do you think that there is the possibility, or are there implications of the other 5 studies for the safe, sustainable by design framework, especially the framework that has been established by European Commission?
Yes. Yes, I think that the exposome, the concept of exposome is the best way. I mean, we can generate the best results in order to promote more and more the safe and sustainability. We can we can conduct a hazard assessment under the exposome concept, and thus we can know all the hazardous effects that can be generated to human health by specific pollutants. In this case, for example, in my case, we have developed, we know already the toxicity, the potential toxicity of the titanium dioxide, and thus we chose to embody, to incorporate the nanoparticles into the body of the tiles, thus block its release and the implications to human and also to the environment. So I think that exposome is the best way to assess also the exposure and the hazard identification of different pollutants, but not only pollutants, also of everyday products. Like we know that currently, we use semiconductors, photovoltaics, but we don't know after how many years, maybe there is a release of a metal or a polymeric material that is used as a semiconductor. So under the exposome, we can test the hazard of all the materials used, and thus we can proceed with the finest selection to construct, to develop new materials for a zero toxicity environment and also sustainable.
Do you think that can be also implication for REACH legislation about the use of exposome?
Yes, because the exposome was built under the REACH regulation of the European Commission. So I think REACH was established in 2005, if I'm not mistaken. And at the same year, its exposome was established as a concept.
Okay.
Do the other members also have questions? Yes.
Congratulations for your works. There are a lot of materials into one single thesis. It's amazing. Just a comment and a question about the arsenic.
The arsenic?
The arsenic, yes, because I found very interesting the fact that the arsenic is a natural pollutant. So we cannot manage as an industrial process. We cannot turn off, turn on an activity. So we have to think about this problem in a different way, probably. And I was...
in order to assess its hazard and
yes,
also...
to take care of our health, to slow down to the exposure. And I have a question about your results, because you found some differences between groups and countries. And I read in your thesis that the major source of exposure is from diet.
Yes.
Diet and drinking water. So
yes.
Do you think that your results are explainable with the diet?
Yes.
So the major difference for your results is due to the diet, different diets?
Yes, because diet, with diet, the exposure to arsenic is even bigger. Also, I have the same results, not only for blood, but also for urine samples. But due to the limitation of time, I could not put inside. But they correlate exactly with, for example, we can see, as I can interpret, for pregnant women, let's say, in Norway, that in Norway the consumption of fish is bigger than in Belgium. The arsenic internal concentration is bigger than when compared to pregnant women in Belgium. So I think that the route of exposure that contributes most is the dietary.
And do you think that we can manage this kind of problem by suggesting some advisor, for example, don't use water with high level of arsenic to irrigate, to feed animals?
Yes,
in order to slow down the concentration in the food?
Yes. I think that an assessment has to be conducted. We know that the strict regulations of EFSA, but I think that more and more studies should be conducted in order to lower the limits as set by EFSA, because still, even if they are strict, we can see a huge internal concentration of arsenic into the body of all the population groups.
Thank you. I have no more questions. Congratulations.
I think that is also important to differentiate organic and inorganic arsenic, because we know that inorganic arsenic is carcinogenic and is toxic.
Yes.
So I think that is another interesting point, no?
Yes, indeed. In total, there are 4 species of arsenic to which arsenic is excreted from the body, 4 metabolites. arsenite and arsenate, which are trivalent and pentavalent arsenic, and also monomethylated and demethylated arsenic. And we did also this research. We found out that the most abundant during dietary exposure methylated arsenic.
From the evaluation. No. Okay. Thank you once again. We finished the three presentations. I would now ask the committee to meet here at Mo to announce the hopeful outcome. Okay, so you can now and come back around 12:50 if you want to watch this final decision. Thank you. Cosa? Okay.